Welcome everyone to the Xojo webinar. I'm Paul Lefevre, the Xojo Developer Evangelist. Our topic this time is object-oriented programming concepts. So, what is object-oriented programming? Well, as the name kind of implies, it's a style of programming based on these things called objects. And those are data structures that contain either data or code. The data would be in properties, is how it's referred to in most languages, including Xojo, and the code would be in methods, which can be subroutines, functions, that sort of thing. These data structures are actually called classes. So when you're designing your apps, you're creating classes that you will use as objects as you're coding and your app is running. And essentially, classes are the fundamental building blocks of all your Xojo applications. Now, you don't have to take advantage of programming, object-oriented programming, when you're designing your own stuff. But the Xojo framework is object-oriented. The design of UIs is. And once you get this overview of how it can be helpful to you, I bet you're going to want to be taking advantage of it as well. So there's 6 concepts I want to touch on today. And these are only 6. This is object-oriented programming is a very large topic. There are college courses on this that take 6 months. So a short webinar isn't going to be able to cover everything. But there's a few things here I want to hit on and give you a couple examples of to maybe help get the gears going. So, of course, we're going to talk a little bit about classes and objects and how objects are made from classes. Objects are also sometimes referred to as instances. And then we'll talk about some of the benefits you get with object-oriented programming, encapsulation, overloading of method calls, inheritance, and overriding. So first, a little bit about classes. Now, these are called classes because it's a way to classify something. You're creating a data structure that has some meaning. It's designed to represent something that your app needs to work with. And as I mentioned, these are the fundamental building blocks of object-oriented programming. Everything kind of starts here. And these classes are essentially become the definition of the objects that your app uses as it does its thing. And the data is referred to or is contained in properties in the case of Xojo. I think most programming languages are also going to use that general term. And then you're going to write code in your classes, and these will be in methods. And that's how you're writing your code, designing it, and whatnot. The objects are how you're going to use these things. So an object is an instance of a class. You have your class design, and you can kind of make it real, so to speak, by creating it as an object that you can then use and interact with. And objects are totally independent from one another. So it's important to understand that you can have a single class, but from it, you can create multiple objects from that one class, each of them totally independent from each other. And that is a pretty necessary thing when you're working with object-oriented programming, because that gives you the independence of, not having to manage stuff or worry about how something might step on something else. When you have the object, the data is also stored in the property that you defined in the class. And then you call or use the methods that you've written for kicking off actions or communicating or that sort of thing. Now think of when you're just doing a layout of some kind, say in Xojo, and you've got an empty layout editor and you drag a button onto it. Well, if it's a desktop app, that button, the class for it is push button. So that's the class. When you drag it onto the layout, you're essentially telling Xojo you want an instance of that class here on the layout, and that gets its own name, and that object becomes, say, push button 1, unless you rename it to be like OK button or save button or something like that. And of course, you can have multiple buttons on that layout. And each of those buttons are totally independent. So if you change the caption on one button, the caption on all the other buttons doesn't also change. That would kind of be bad and defeat the purpose. So that's kind of how you're interacting with objects when you're just doing your layout design. But not talking about layout, let's consider an example. So let's say you have to track vehicles for an automobile dealer. How would you go about doing that? We're going to track the vehicle, and we'll just talk about a few parts. So you want to track what the make of the vehicle is, what its model is. So it'd be like, Honda Accord. And say you just want to track the mileage. Not going to put a lot of stuff in here for now, but you certainly have other things that you want to track. So how would you implement this sort of thing? Let's switch over to Xojo and take a peek. All right, so here I have a Xojo project, and this is very simple. I'm just going to run it so you can see what it does, and then we'll look at how it works under the hood here. So I can add vehicles here to the list. I can click on a vehicle and press details to have it specifically show up there. So very simple, kind of a list detail kind of thing. This example does not use object-oriented programming for managing those vehicles. So if you look at the window that's on here right now, you can see what it's using is something I see people do when they don't have much experience with object-oriented programming, is they start with the data structures they do know. So in this case, arrays. So this has 3 arrays, one for each of the things you want to track for the vehicle. So it has an array for the make, the mileage, and the model. And then what happens here, when vehicle gets, you want to add a new vehicle, essentially we're just adding each of those to the array. And they're all at the same position, so just adding each to the end of the array. So we're adding whatever was typed into the make and the model, and then adding a no mileage to start with for the vehicle. And then the list box gets reloaded to redisplay the contents of what's in the array. And as you can see, when I ran the project, this worked just fine. The problem is when you start to work with something like this, as things get more complicated, or you need to do more in your project, this design starts to get a bit unwieldy. Say you want to remove something, you have to remember to remove it from all 3 arrays. If your array gets out of sync, and say you accidentally only remove a model and forget to remove the make and the mileage, all of a sudden your data is totally kind of hosed because you've got makes that no longer apply to the appropriate model because you just had everything connected by a single index. If you needed to track more information about the vehicles in this design, you'd have to add a lot more arrays. And that also will get even harder and harder to manage. And then little things like these all provide direct access to everything. So in the case of the mileage, you can change the mileage to whatever you want. So there's no control over it. And in particular with automobiles, you generally don't reduce mileage on cars. It only gets added. But by having direct access like this, you could reset mileage to 0 or whatever you wanted. And that generally doesn't mirror the real world too well. So that's a little bit of a problem there. So this is what a design looks like when it's more simple, using just something like arrays. Now let's see how we might do this using object-oriented programming. Same layout. And you see the project has a new item here called a class. You add classes just by going to the insert button here and choosing class. And a class is, just a container here. And you can see on this class, there's a couple things. There's a method and some properties. The properties are tracking the things we want to track about the vehicle. So because this is all about the vehicle, the class is named vehicle in this case. You could call it whatever you wanted that made sense. And then the properties that are on here, make is just a string, as is model. And then mileage looks a little different here. I have a mileage property that's showing up as red because this indicates it's private. And that means that it cannot be accessed from outside the class itself. And then I have here a computed property. And this only has a getter implemented. So this means that if you access the mileage property from outside the class itself, you'll only be able to get the mileage. You won't be able to directly change it. And that prevents direct manipulation of the mileage, such as clearing it or anything like that. And then what I've added here is an add mileage method that you can call that will always just append the miles to whatever is currently in the mileage, theoretically preventing you from reducing the mileage. Now, I don't have any code in here that says, make sure the miles parameter is greater than 0. That probably would have been a good thing here. So if miles is greater than 0, then add it. But that's the sort of thing that, having a class allows you to do, is you can put that code right where it belongs here in the vehicle class to control the vehicle information itself, rather than having it in other parts of the code where maybe it might be harder to find later, or even worse, where you might have to duplicate that code. So I've now designed my class, the vehicle class. It has these items on it. So how does it get used? Well, the same thing. When you click the button to add a new vehicle, well, the code looks exactly like that. I want to add a new vehicle. So I'm going to create a variable, and I'm going to use the new keyword and create a new instance or a new object using the vehicle class. That is now referred to in the v variable. And then I can access the properties here and set values to them. And then the list of vehicles overall is stored in its own array, but it's just one array here that you have to maintain. So if I want to remove a vehicle, I just remove it from the array, and that's it. It's gone, and all its associated data is gone along with it, so I don't have to manage things independently. So nice and clean. And if it turns out I need to add more properties to the vehicle or anything like that, I can just add them to the vehicle class and then set them here. And the array still is just a single array that manages all that. And if I look at the load list box routine here, you can see that it just loops through all the vehicles that are in the array and adds the appropriate properties to the list to display. And then one little thing it does here is it saves in the row tag the actual object. So I can pull it out later and have an actual object that I can then use to grab the data from to display, say, in the details window or something like that. All right, so that's how an object-oriented implementation could be used instead of the array implementation. All right, now I want to talk about some of the features that you get when you're using object-oriented coding. And some of them I've touched on a bit before, but give them actual names here. So encapsulation. This is where you can hide or control information that does not need to be accessed or modified from outside the class. So I kind of showed this a bit with the mileage computed property that was on the vehicle class. I had the actual property, the integer property that's storing the mileage, as private so that nothing could directly access it. And then I had the computed property set to just return its value and not allow it to be modified. And then I had a companion method that allowed mileage to be added, but never, well, theoretically, once I fixed that, I suppose you could call it a bug almost. Once I added that other line of code, you would never be able to reduce the mileage. You'd only be able to increase it. So all that is encapsulated or contained within the vehicle class itself, right where it belongs, where it makes sense. And that's a big, big benefit of object-oriented programming. And as I made with the mileage property that was private, the non-computed one, you can also make methods private, and it's a great way to hide information. One technique I often use when I'm designing things is I'll try to make my things private right from the get-go. So when I start adding, properties and methods to my classes, I'll start by making them private to begin with. And then if it turns out in my design that I actually have a good reason to access it outside the class, I will consider that and then maybe flip it up to be public so that it can be accessed. And this gives you a bit of a safety net so that you don't perhaps use your class in ways that might make things more fragile later on down the line. So overloading is another thing I want to mention. Now, technically, this is not really an object-oriented programming thing. You can overload methods that are not in classes if you have them in a module or something like that. But it's a common technique used in classes, so I want to highlight it here. And overloading is where you have multiple methods with the same name, but they have different parameters. And these parameters can vary by either the number of parameters or by the data types of the parameters. So as an example, consider the vehicle class again. And say we wanted to add a new method on there that let you transfer the vehicle to someone else. So you want to transfer ownership of the vehicle. Well, you can see here I could create a transfer ownership method, and I could have it as a parameter. I could pass in the name of, say, the new dealer that's going to be now the owner of the vehicle. But the point of the dealership is to actually sell the cars, and often that's to customers. So I may want to have the same method, but have a different parameter. So here they both just have one parameter, but they have different data types. The first one's data type is dealer, which would be a class, and the second one is customer, which could be a different class. So that's one way you could take advantage of overloading. Now, you don't always have to use overloading. I could have just named these methods differently. I could have called the first one transfer ownership to dealer, and the second one transfer ownership to customer. Could have done that, and then they're totally independent. But sometimes for ease of use, it makes sense to just use the same name and allow different parameters to be used along with it. But that's more of a design decision on your part. Now, inheritance is a big benefit of object-oriented programming and commonly used. And this is where you create a class that is actually based on an existing class. So this is what's actually happening when you're working in, say, layout screen, and you drag, you're working on a desktop layout, and you drag a push button from the library onto the layout. Well, as I mentioned, the push button is the class. And actually, I probably don't want to go with push button. Yeah, I guess I can. So you drag push button onto the layout. And but push button is a class, but it inherits from another class. There's actually a class above it in the Xojo UI framework, and it is called rect control. And that is for any control that can appear on a layout. And this rect control class contains commonly used properties for all the visual controls, things like the top position, the left position. I'm trying to think of something else off the top of my head. Maybe the visibility might be on there. But anyway, common stuff that's used across a bunch of classes is in this rect control class. And then push button inherits from rect control. So it's a way to prevent you from having to repeat things across all your classes. So essentially, this class that is based on the existing class is more specific in some way. And you can also add additional properties and methods to this new class. So, it's based on the other class, but you can make it more specific. You can add more properties to it, more methods. And this is called subclassing. And when you do that, the parent class can also be called the superclass. And so here that And you'll see that in the Xojo inspector. There'll be a field next to a class called super that lets you select what the parent class is. And then when you do have a subclass, you can do something called overriding. And this is where a subclass method is used instead of the parent or the superclass method. And we'll look at some examples in a second of how that can be used. And the last thing I want to touch on, it wasn't on my list, is something called polymorphism. And this is kind of a bonus object-oriented feature, but all of the stuff I've described gives you this capability, and it essentially allows you to have different classes behave in a uniform manner. And you can do this by taking advantage of overriding in combination with inheritance. And I'm going to show a couple examples kind of tying all these things together that use overriding to implement this. And also another one that uses Xojo's event capability, which commonly is used for UI controls to get events when things happen, but can also be used with non-UI controls to implement stuff like this. So let's switch back to Xojo. All right, so here I have 3 classes. I have a class called animal. These are very simple classes, of course. And it has just one method on it called speak. This method doesn't even have any code in it. It's empty. That's it. That's all that's on this class. Then I have 2 other classes here, dog and cat. And if I click on dog, you can see over here that super is animal. So the dog is an animal. And that means it inherits the speak method, which, as we saw, it doesn't have any code in it, so it doesn't do anything. But here I can override it. So I can choose it from the drop-down here, and it'll appear as a method I can just pick, and then I can put my own code in it. So in this case, I just have code here that makes the dog sound. And then similarly, cat also inherits from animal and has its own speak method. So in this very simple example here, I have a class, I've got a method. 2 other classes are inheriting this class, and they're overriding the method that's in the superclass. Now, what's the benefit of that? Well, I can now kind of treat those classes very, very similarly. So here I can create an array of type animal. So that's the parent class. But I can append into the array cats and dogs. So here I'm adding a cat, and then here I'm adding a dog to the array. And that works because a cat is an animal and a dog is an animal. So I can add those to the array just fine. And then I can loop through the array. I just do a for each here. And then when I loop through, I'm getting back an animal in the A variable. And then I can call the speak method. And I can call the speak method because it's on the animal class. But even though the one on the animal class doesn't have any code, this is going to know which thing it actually is. So even though it'll be an animal, it'll know, well, A is actually, the first one's actually a cat, and the second one's actually a dog. So I'm going to call the cat speak method when I know it's a cat, and I'll call the dog speak method when I know it's a dog. And if we run this, we'll end up seeing that it does that. So we get the meow, and then we get the woof. So very, very useful technique. Now I have multiple things here, but I get to treat them very similarly in my code and call a method on them without specifically knowing what is what. It allows for, a pretty clean design here. I don't have a lot of if statements or anything to check what things are. I can just use them. Now, Xojo also has another technique that allows this with its events. And in this case, you can see I still have 3 classes here. Animal is still the first class, still has a speak method. But in this case, I've added an event definition. You can add your own event definitions to classes just by going to the Add button and picking Event Definition. And then when you create an event definition, you can't put code in here or anything. All you can do is specify the name and any parameters and return types. So this is just a definition. And here, the speak method actually does have a little bit of code. It is saying return whatever. Well, it says return, and then what it's returning is it's calling the speak sound event and returning whatever it returns, since that is defined to return a string. So that's what that is doing. Now, if we just created an animal and called the speak method, again, it wouldn't do anything because there'd be no code in the speak sound event. But if I look at my dog and cat subclasses, so you can see again, they inherit from animal. Instead of adding a method to these, I went to add event handler and added the speak sound event. And here I can put the same code. So I can return what I want. And the same thing on a dog. Now this design is kind of nice because event handlers for some people are easier to work with. You don't have to worry about overriding a method. Maybe, accidentally changing the name or something like that so that things don't work the way you want. But the usage is exactly the same as the other technique. So you can see here the code, this code is exactly the same. I create an animal, I can add a cat and a dog to it, and then I can call the speak method. Now what's happening behind the scenes is a little different. In the previous example, when the speak method was called, it would actually call the speak method on the cat object or the dog object, depending on which one was in the array. Here it's always calling the speak method on the animal. But the speak method ends up calling the event on the appropriate subclass. And then when this is run, you get the same results, cat and the dog speak. All right, so that kind of gives you a kind of high level of how some of those things can be used. So I want to point you to a few resources. Remember, you can always get the latest version of Xojo from xojo.com/download. I always recommend you do that. If you're new to Xojo or even new to programming, you can grab our free book, Introduction to Programming with Xojo, from xojo.com/learn. And I always encourage people to head over to the Xojo forum. It's a great place to ask questions. There's a Getting Started channel in there where you can ask just about anything, get some good tips, bounce ideas off people, that sort of thing. And of course, you can learn more at the Xojo Dev Center, developer.xojo.com, where the full user guide exists and videos and lots of other things. And that about wraps things up here. You can always reach me via email, paul@xojo.com, and of course on Twitter, @Lefevre or @Xojo. If you have, short questions, Twitter can be great, but it's not great for long things. So take advantage of email. Shoot me a note if you got a question. I believe in August, I'm doing another object-oriented related webinar on some more advanced topics, probably cover interfaces and a few other things. So be sure to check out the webinar page at xojo.com and register for those if you're interested. I want to thank everyone for attending. Have a great day.